Hema says 10, Pratna, Anuja, Sthiti, Shital. Looks like all girls are answering. Aza, Kritika. Guys, where are you? Are you still searching for a calculator? By the way, calculator doesn't give me reminders. So, Manashvi, Nirupama, Anushka, come on. Pranav, great. Preeta. Okay. So, Vinita, Divya, all of you got 10. Great. So, most of you, not most of you, as of now, all of you have got it right. Now, let's understand how did you get this right? What did you do? Did you do 1, 3, 4, 3, 3, 1, and you divided by 11? This is what most of you would have done, right? ये जो board में दिख रहा है ऐसे ही किया होगा तुम लोग, right? So 11 ones are 11, then 24, right? 11 twos are 22, then 23, 11 twos are 22, then 113, 11 ones are 11, then 221, 11 ones are 11, and the difference is 10. So 10 is a remainder. Great. So this is what you've done. So if I have to do it on a very, very quicker way, right? Remember we started, yesterday we did divisibility rule of 11, and what did we do? When I say yesterday, it was the last class, okay? And what did we do? Tell about 11's divisibility rule. We said that for 11's divisibility rule, the difference between the sum of the digits in the even places and the sum of the digits in the odd places should be 0 or a multiple of 11. So when I have 1, 3, 4, 3, 3, 1, I can take this value as odd places and I can take this value as even places. Now remember this, that if I may not be wrong in taking these values as odd places and these values as even places. Do you understand the difference that has happened? From when I took this, from my left hand side, I took the numbers. So 1, 4, 3 became the digits in the odd places when I started counting from the left hand side. But the same thing when I start counting from the right hand side, 1, 3, 3 became odd places. Understood the difference? One is when you're counting odd places and even places from the left hand side of your number, and one is when you count the odd places and even places from the right hand side of the number. Okay? So let's look at the right hand side of the number. Now, if I'm counting numbers from the right hand side, then 1, 3, and 3. These are odd places, which means I have a sum of 7. And 3, 4, 1 is from even places, which is having a sum of 8. Okay? So what is 7 minus 8? It's minus 1. 7 minus 8 is minus 1. Means that my remainder, when this value is divided by 11, is actually minus 1. But minus 1 cannot be given as a remainder, correct? What does the concept of minus 1 remainder means? It means that let's assume that I'm dividing 10 by 11. When I divide 10 by 11, what is the remainder? 10 is a remainder. Or I can actually also say that when 10 is dividing by 11, the remainder is also minus 1. So you guys can give remainders in two ways. One, a positive value, and one, a negative value. So if your negative value is a remainder, then your real remainder is 11, which is the number that you're dividing by, minus the negative value. How much is that? 10. And that is what the remainder is when you're dividing this by 11. which means I do not have to divide a value by, to see. I can use the divisibility rule. That's what this means. So for example, if I have to say that, let's give some other example here. Let's say if someone wants to say what is the remainder when 3, 1, 3, 2, 3, 4, 5, 6 is divided by 9. I do not have to actually divide this by 9, guys. What is my divisibility rule of 9? Sum of the digits, remember? So do the sum of the digits. 3 plus 1, 4, 4 plus 3, 7, 7 plus 2, 9, 9 plus 3, 12, 12 plus 4, 16, 16 plus 5, 21, 21 plus 1, 6, 27. Divisible by 9, so remainder is 0. If this was 1, 3, 1, 3, 2, 3, 4, 5, 6, then my sum would have been 28. What is the remainder when 28 is?
Anand sir, you are not audible to us.
Yeah, sir, you're not audible. Sir, you're not audible.
Just a moment, he will be back.
He's doing it, yeah.
Am I audible, guys, now?
Yes, sir.
Thank
Yes,
you.
sir.
Unfortunately, even the volume got shifted out, so I couldn't hear any one of you. Okay, right. So I do not know where did you guys lose me?
28 divided by 9.
Right. So when we do 28 divided by 9, what is the remainder we get? We get 1 as a remainder, correct? Which means this entire number when divided by 9 gives me 1 as a remainder. So typically saying that if there is a question on remainder, I can find the answer by using divisibility rule itself. I do not have to divide. And got it? Right? Okay, great. So that's where the entire composite numbers also came into picture. So now we will proceed further.
I have a doubt.
Yes, please.
I'm Indrija. The before question, yeah, this one. So the digits are 1, 3, 4, 3, and 1.
Okay.
I first took 1 plus 4 plus 3, which is equal to 8.
That was divided by 11 is what you're talking about, right?
Yeah, the one which you asked, the before one.
Yeah,
so
right.
Yeah, so 1 plus 4 plus 3 is equal to 8. And then 3 plus 3 plus 1 is equal to 7. So 8 minus 7 will give me 1.
Correct.
Is what I did. But then you did 3 plus 3 plus 1, 7 first, and then the 1 plus 4 plus 3 next. So you're not audible.
Right. So when I do from left hand side to right hand side, I realize that, am I audible now?
Yes,
right.
Yes, you are.
Great. So when I'm doing from left hand side to right hand side, okay. So just sorry, I'm going off. Anushka, Nirupama, I can see you guys on my screen. Okay. So whenever I'm not audible, just show me a hand. Will you be able to? Right? But it doesn't mean that you keep looking only at me. Look at the screen. But as soon as I'm not audible, just show me your hand. Right? Because you are the two people I can see on my screen. I can't see the rest of it unless I scroll down. Right. So now we are talking about digits which are in the odd place and digits which are in the even places. Now understand this, the odd place and even place is completely also dependent on whether I'm reading the digits from left to right or I'm reading from the digits from the right to left. Now let's assume that I'm doing it from left to right. Then 1, 4 and 3. These are the digits which are in the odd places. So the sum becomes 8. And from the left to right, 3, 3, 1 are the digits in the even places. Remember this, that if I do a subtraction here, this is not the remainder. The remainder is always obtained. Okay? Remainder, especially only for divisibility rule of 11. Okay? Remainder is always obtained when you do from right to left. Only when you do from right to left, odd places and even places, that is when the time you can obtain the remainder. Did I answer your question?
Yes, I understood.
Okay. Now there was someone who said, Ira. Ira said that what if the difference was -4? So Ira, if the difference is any value, let's say in this case it was -1, but let's say the difference was -3, then I will do 11 minus 3. If the difference is -10, then I'll do 11 minus 10. So whatever the difference is, if it is negative, then I will subtract. If it is positive, remember this, if it is positive, then that is my remainder. Okay, if the difference is positive, then that itself is my remainder. But in case your difference is negative, then I will reduce that from the divisor part. Are we clear? Right. Now, getting on to one small question on square, just to remind you where we were in terms of squares. So can you all tell me, type me quickly, answer options, okay? Just type me 1, 2, 3 or 4. Which of this, do not use calculators, guys. Don't use calculators, mobile phones and all to find a square root. Can you tell me which among them is a perfect square or are a perfect square? So that can be more than one option also. So go back to your squares and start thinking about it. All you guys wrote squares from 1 to 25. All of you wrote squares from 1 to 25, right? What happened when you, so Sanjana says 20449. Okay, Sanjana, let's look into that. So all of you wrote squares from 1 to 25, okay? What happened when you wrote squares from 1 to 25? When you squared numbers, 1 ended in 1, 2 square ended in 4, 3 square ends in 9, 4 square is 16, ends in 6, 5 square is 25, ends in 5, 6 square again ends in 6, 7 square ends in 9, 8 square ends in 4, 9 square 81, 1, 10 square ends in 0. Right? So all the values from 1 to 10, when you squared them, they ended in one of these digits. Ended. Okay? So do you think that all the numbers from 11 to 20, when you square, will also end in one of these digits? Do you think that when you square 11 to 20, they will also end in this? Yes, it has to, because 11 square ends in 1, 12 square ends in 2, 13 square ends in 3, 14 square ends in 4. So when you square these values, 11 square will end in 1, 12 square has to end in 4, 13 square has to end in 9, 14 square has to end in 6, correct? So all the values will continue ending in one of these digits, which means that no number square of no number can end in 2, 3, 7, and 8. One learning. Squares of no number can end in 2, 3, 7, 8. Please understand, I'm talking squares of numbers, okay? Not the number itself. Number can be 12, number can be 17. But if you square them, they will never end in 2, 3, 7, or 8. That's number one. Second learning that you guys have to look into is, look at all the squares that we did. When I did a 7 square, I had 49. When I did an 8 square, I had 64. When I did a 9 square, I had 81. When I did 11 square, I had 121. Okay. When I did a 14 square, I had 196. So if you look at them, when a number ended in 9, the previous digit was even. 7 square, let's say 13 square. What is 13 square? 169. Ends in 9, the previous digit is even. 6. When a number ends in 4, the previous digit is even. Let's say 8 square. Let's say 12 square. 12 square is 144. So when it ends in 4, the previous digit is even. When the number ends in 1, the previous digit is also even. When the number ends in 6, the previous digit is odd. Take 4 square for that matter. What is 4 square? 16. It ends in 6, but the previous digit is 1. Right? So 6 square, 36. Ends in 6, previous digit is even. 3. Odd. 3. So I have to look at this. Now let's look at the answer. If a square of a number has to end in 9, what has to be its previous digit? According to 7 square, I know it is 49, which means the previous digit has to be even. Now, since the previous digit is not even, this cannot be a perfect square. 4, previous digit again has to be even. Cannot be a perfect square. Okay. 1, previous digit has to be even. Cannot be a perfect square. 9, previous digit has to be even. Yes, it is even. So this is the only option where the previous digit is even. So if your question has one answer option which is a perfect square, then this has to be the perfect square. There is no other way. Did we understand? So we are not looking at what is the previous, basically the exact square value, perfect square value. We are looking at what is the previous digit. Okay. Right. So just a minute. Give me a minute's time, please. 12, 21, 10, 21, 3. 1, 9, 10, 10, 20, 23, 5. 4, 4, 8, 10, 19, 19, 10, 10, 1. And 10, 20, 30. Okay. Now, I will show you a magic out here, okay? Look at this magic. Uh-oh. Now look at the magic, guys. This is fun. That's why I say maths is fun. Can you add, all of you, can you add the digits of these numbers till you get a single digit? You got to add the digits of the number till you get a single digit. For example, 1 plus 8, 9, 9 plus 7, 16, 16 plus 5, 21, 21 plus 9, 30, 3 plus 0, 3. Okay? 7 plus 1, 8, 8 plus 8, 16, 16 plus 4, 20, 20 plus 1, 21, 2 plus 1, 3, 1 plus 9, 10, 7 plus 3, 10. So that is 20. 20 plus 23. So 23. 2 plus 3, 5. 2 plus 4 plus 4, 10. 10 plus 9, 19. 1 plus 9, 10. 0 plus 1 plus 0, 1. Can you tell me among these these 4 single digits, which is a perfect square? Right? Most of the times you will find that if this number is a perfect square, then the sum of the digits, the unit digit part value will also be a perfect square. 90% of the cases. Which means you can avoid everything else if you want to do it. I mean, I don't think you can get simpler than this. Okay, the most simplest problem. Sorry, yes?
Can you explain this again? I didn't understand.
Okay, so say if there is a value which is a perfect square, then when you add the digits of the value, that sum should usually be a perfect square. Okay, usually. I'm not saying always. So let's say in this case, I add the digits of all these values till I get a single digit number. So I added this, I got 30, 3 plus 0 is 3. Now 3 is not a perfect square, correct? So since 3 is not a perfect square, this will mostly 90% times, this will not be a perfect square. I'm not saying always. Because this is not universally true. This works only for bigger numbers, doesn't work for small numbers. For example, let's say, what is 14 square, guys? 196. Look at the sum of this, 1 plus 9 plus 6. What is 1 plus 9 plus 6? 16. What is 1 plus 6?
7.
This is not a perfect square, whereas this is perfect square. Right? So this doesn't work always. You got to keep manipulate depending on whether you get a perfect square. So I did not get a perfect square here. 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 And thus I went ahead with one more step and then I found a perfect square in this. Because I didn't get it here also. I found it in this. If I get a perfect square right here, just like I got 16, then this becomes a perfect square. So you got to get a perfect square when you sum the digits. So this is where I'm saying 90% of the time it works. 10% you'll always have a chance. So why I'm saying this? Instead of leaving a question of how to do and how not to do it this way. That's what I'm saying. Understood? Rather than leaving a question. So for example, okay, perfect square, it was easy. All of you know what a perfect square is. So most of you able to answer this 20449 by doing your question. So Pritika was able to answer and few of you were able to answer this. But let's assume that I was not giving you a perfect square, but giving you a perfect cube. Now who will sit and do perfect cube? So most of us will leave this question, right? Ki kaun banayega perfect cube? So this is one of the method where you can try and look into, can I get a perfect cube concept rather than directly leaving this question. That's the idea. So don't avoid a question without attempting it. Done? Are you clear now how we got this? Can anyone answer this question? All of you? You have to type in your answer option. That's it. ABC is a 3-digit number divisible by 7. Which of the following statements is always true? Sanika, yes, you can use the same method for cube also. Oh, why everyone is so fast in typing D? Rule of a competitive exam. Okay, that's a good part of people who teach you competitive exams and those who have especially with the experience of also creating one. Rule of a competitive exam. None of these is most oftenly not my answer. Okay, 99% of the time, none of this is not my answer. And 99% of the time cannot be determined is always my answer. In case you want to guess. In case you want to guess. Okay. So how do I solve these kinds of questions which comes into, the bracket? Two ways, guys. Choose the way you like to solve. So I will teach you both the ways. One, a 3-digit number ABC. What place value is C? Units place, right? What place value is B? Tens place. And what's place value of A? Hundreds place. Basically means that if I have a number 346, how do I say this number? I say this number as 346. Why do I say it as 346? Because 6 gets the face value and the place value. 4 gets the face value and the place value. 3 gets the face value and the place value. So you end up writing 346 as 300 plus 40 plus 6. So now in case, if that is the case, then can I write ABC as A into 100 plus B into 10 plus C into 1? Can I do this, guys? Yes, taking the face value and the place value. Now, I am looking at a number divisible by 7. Oh, sorry, my mistake. I'm looking at a number divisible by 7. So how do I find a number divisible by 7? First, I know that if I look at 100 times of A, I know that 98 is divisible by 7. Is 98 divisible by 7, guys? Divide and see. 7 ones are 7, 2 carry over 28, 7 fours are 28. Yeah, it is. So out of 100A, I take 98A, and if 98A is taken, how much is left over with me? 2A is left with me. Where this portion is divisible by 7. This portion I don't know. Similarly, if I take 10B, can I say B plus 3B, where this portion is divisible by 7, whereas this portion I don't know. Right? And now what am I left with? I am left with now C. So what are the values that is there in my hand which is divisible by 7? 98A is divisible by 7 and 7B is also divisible by 7. So these are the two values that I have in my hand which is divisible by 7. I know it. But the values that I do not know whether divisible by 7, they are 2A plus 3B plus C. This is the value which I have in my hand, which I do not know whether divisible by 7. So in case if this value is divisible by 7, then the entire value will be divisible by 7. The entire ABC will be divisible by 7. So which implies that this is my answer option. Now for those who feel कि यार कुछ समझ में नहीं आया, I didn't understand anything, right? So this is complicated. I don't want to touch base to this. So for all of you who come into that category, let's ignore all this thing. And I want you to tell me smallest 3-digit number, because you are talking about ABC and a 3-digit number. So tell me a smallest 3-digit number which is divisible by 7. Can you guys tell me quickly the smallest 3-digit number which is divisible by 7? Thanks, Pritika. So Pritika says 105. Why don't you guys check whether 105 is the right one? Is 105 divisible by 7? Yes. So now let's say this is my 3-digit number. So if I have to compare with ABC, what is the value of A? What is the value of B? What is the value of C? Can I substitute this in all my answer options and see? Check. A is 1, B is 0, C is 5. 1 plus 0 plus 5. The sum is 6. Is 6 divisible by 7? Absolutely no. Second option. 2 into 1 is 2. This is anyway 0 plus 5. 2 plus 5, 7. Is 7 divisible by 7? Yes. So that's another way of answering the question where you take a value. You do not have to take only smallest number, guys. You can take any value. For example, I do not know maths, so I will take 777. Is 777 divisible by 7? Yes, it is. Right? Then I'll substitute here to see what is it. But the problem in this case is 777 will be applicable for all of them, unfortunately. So you'll have to end up using another one. So always use 1 or 2 different values. Substitute and get the right option. Done, guys?